to go?
Yeah.
So our unit was Unit 7, Part 2, Trigonometry. In our video, we're going to be covering reference angles, coterminal angles, figuring out what quadrant the terminal side lies in, the unit circle, finding the measures of angles given its trig value, degrees to radians, radians to degrees, and simplifying trig expressions. So the first thing is reference angles. A reference angle is the positive acute angle that's measured against the x-axis. So an example is find the measure of the reference angle for a 140-degree angle. First thing you want to do is you want to draw where you think that the angle would line up. So you start here and you're going to go. So I labeled it 0, 90, 180, and 270. Also can double as 360. And I guess that it's 140 right about here, because I know it's between 90 and 180. So when you have your angle, you're going to drop it down to the closest x-axis, either 180 or 360. So I dropped it down to 180, and I'm looking for this angle right here. So I do 180 minus 140, which is equal to 40 degrees. And we know that that's an acute angle. It's between 0 and 90, so you know that 40 degrees is the reference angle. So example number 2, reference angle for a 350-degree angle. First thing I did again was draw it, and I know that 350 degrees is just a little bit below 360, so I drew it out there, and I dropped it to the closest x-axis. This time it was 360. So I dropped it up there, and I'm looking for this angle. So 360 minus 350 equals 10. Now it can never be negative, so just keep in mind that it's a distance positive. Like in degrees, you can also find reference angles in radians. So find the reference angle for 15 pi over 16. So first of all, I drew the axis again, and I know this is 2 pi, pi over 2, pi, and 3 pi over 2. It's a lot easier if you convert these pi's into a same base as what you're working with. So that's what I did. I figured out that 15 over 16 is just a little bit less than 16 over 16, and so I drew the angle right there. Dropping it down to the x-axis again, I try to solve. So you're left with 16 pi over 16 minus 15 pi over 16, which would equal pi over 16, which makes that's the reference angle. So now here are some u-tries, and just pause the video if you want to try them. And here are the answers. For the first one, it's 60 degrees. The second one is pi over 8. The third one is 20 degrees. And the fourth one is pi over 7. Second thing we're going to be talking about is coterminal angles, and those are angles that have the same initial side and the same terminal side, but different rotations. And an important note to note is that it can be more than one full rotation. It's pretty simple to find these. If you're in degrees, all you got to do is add or subtract 360. So an example is find a positive and negative coterminal angle for 75 degrees. All I did was I subtracted 360 from 75 and added 360 to 75. And I got my answers to be negative 285 and 435 degrees. Now there's endless possibilities. You could keep subtracting 360 and adding 360, but these are just the most simple. And in radians, it's just multiples of 2 pi, because you know one full rotation is 2 pi. So an example is 15 pi over 36. Now, I converted 2 pi to the same base as 36 to make it a little easier, and when I added 72 pi over 36, which is equal to 2 pi, and subtracted it, I came up with 87 pi over 36 and negative 57 pi over 36. The next thing we're going to learn is how to tell what quadrant the terminal side lies in. So first you need to know what a terminal side is. This is a picture of standard position. The initial side is right here, and the terminal side is what happens after you rotate. So an example would be 45 degrees. This right here would be the initial side, but once I rotate, it would be 45 right here. And I know that would be in quadrant 1. In radians, it's pretty much the same thing, except, of course, it's going to be in radians. So 5 pi over 3. Now, I labeled mine according to what I know, and I determined that 5 pi over 3 is right about over here. And it's pretty easy if you just want to convert these into over 3. So that would be 4.5 pi over 3, and that's how I figured out it would be a little bit more than that. So the answer would be quadrant 4, as we know 1, 2, 3, 4. And here are a couple u-tries. And here are the answers. For number 1, 160 degrees, it is quadrant 2, and for number 2, it would be quadrant 4.
Alright, here we move on to the unit circle. We use the unit circle to easily find trig functions. So here you can see that we start at 0 degrees, also known as 360 degrees, with a coordinate of 1, 0, and the radian is 2 pi. At 30 degrees, the radian starts at pi over 6, and with each increase of 30 degrees, you go up by pi over 6. So here we have 2 pi over 6 is equal to pi over 3. And these are the coordinates you'll have for every quadrant, but in certain quadrants they're negative and positive. So for 30 degrees we have the square root of 3 over 2, comma 1/2. And 45 degrees we have the square root of 2 over 2, comma square root 2 over 2. And 60 degrees we have 1/2, comma square root 3 over 2. And then we get to 90 degrees, which has the coordinates of 0, comma 1. And you also note that for radians, for increments of 15 degrees, it starts at pi over 4 at 45 degrees, and it'll increase by 2 pi over 4 each time. So down to the other quadrants. All coordinates mirror across axes, but quadrant 2 will have a negative x and a positive y, quadrant 3 will have a negative x and y, and quadrant 4 will have a positive x and negative y. The angles. Angles always increase by 30 degrees unless it's to or from the angle in the middle of a quadrant. In that case, it's an increase of 15 degrees, and as I previously stated, for radians, for angle increases of 30 degrees, radians increase by pi over 6. For angle increases of 15 degrees, radians increase by 2 pi over 4, starting with pi over 4. And examples are 135 degrees equals 3 pi over 4 in radians, and 120 degrees equals 4 pi over 6 in radians, which is also equal to 2 pi over 3. Finding the angle measures. So here we have our basic unit circle all drawn out, and each of these is how you find specific trig functions when you're given an exact value. So for cosine, you would find the x-coordinate, and sine, you would find the y-coordinate. For tangent, you would find the y-coordinate over the x-coordinate. Secant, 1 over the x-coordinate. Cosecant, 1 over the y-coordinate. And cotangent, x-coordinate over the y-coordinate. So here are the examples here. Cosine of square root of 3 over 2. You'll see up here we have, this is the x value because of our x-coordinate. It's right here at 30 degrees and 330 degrees. We have the x value of square root 3 over 2. So it's labeled here. And we also have that in radians, which is pi over 6 for 30 degrees and 11 pi over 6 for 330 degrees. And then another example, secant of 2 over square root 2. So again, for secant, it's 1 over the x-coordinate. So you see here that 1 over square root 2 over 2 is equal to 2 over square root 2. So we have that here at 45 degrees and here at 315 degrees. And we also have that labeled in radians, pi over 4 and 7 pi over 4. And then we have our u-tris here. You may have already seen the answers, but here they are again. Yeah, so answer number 1, 45 degrees or 225 degrees, and pi over 4 or 5 pi over 4. And then number 2, 90 degrees or pi over 2 in radians.
In order to convert a radian into a degree, you have to take the radian, multiply it by 180, and divide it by pi. So here in this example, the radian is 5 pi over 2. So you have to, what I said is divide by pi and also multiply it by 180. So the next step is to take the side and multiply over here. So it'll be 5 pi over 2 times 180 equals pi over the degree. So then you can convert it over to the denominator by dividing it. So it's 5 pi times 180 over 2 times pi, which equals the degrees. After that, you can simplify and multiply it up on the numerator, which gets 450. Now here's the u-tri. Alright, the answer should be 315 over 2, or 157.5 degrees, and here's the explanation of how I got that. Now the next one is the opposite, is converting degrees into radians. So in order to convert a degree into a radian, you have to take the degree, multiply by pi, and divide by 180. So in the example, I have 270 degrees, and I'm multiplying it by pi over 180. After that, I put the 270 up in the numerator, and it becomes 270 pi over 180. And after that, I simplified, which then I got 3 pi over 2. So in the problem, convert 420 degrees into radians. The answer you should got is 7 pi over 3 after you simplified the 420 over 180. Good.
Right.
Our final topic is simplifying trig expressions using reciprocal, Pythagorean, and quotient identities. So the reciprocal identities are sine equals 1 over cosecant, cosine equals 1 over secant, tangent equals 1 over cotangent, and for the other three, it basically just flips. So that would be cosecant equals 1 over sine, secant equals 1 over cosine, and cotangent equals 1 over tan. So for the Pythagorean identities, the first one you need to know is sine squared plus cosine squared equals 1. And there are two others, 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. Now, for the Pythagorean identities though, if you know sine squared plus cosine squared equals 1, all you have to do is divide the whole thing by cosine to get 1, and then the whole thing by sine to get the other one. The last ones are the quotient identities, and so the first one is tangent equals sine over cosine, and then cotangent equals cosine over sine. So you're going to use these properties to simplify. So the first example is tangent squared plus 1 over 1 plus cotangent squared. So we know that tangent squared plus 1 is equal to secant squared from one of our identities, and then we also know 1 plus cotangent squared is equal to cosecant squared by our other identities. If we go over here, we can use our reciprocal identities to know that secant is 1 over cosine, and cosecant is 1 over sine, and that's how I got that. And then it equals to sine over cosine squared, which you know is tangent squared from our quotient identities. The second example is secant tangent over tangent squared plus 1. So tangent squared plus 1, again, is secant squared, and then I just left out the same. Going now, you know that secant squared is equal to 1 over cosine squared, so I put it over here, and I can cross out one of the cosines, but I still have one left, so I have cosine and tangent. Cosine, I keep cosine the same, and we know tangent is sine over cosine. I can cross out the cosines, and I'm just left with sine. Number 3, secant minus cosine over secant. So what I did was I broke it up. You know that this is equal to secant over secant minus cosine over secant. And then you know that secant versus secant is just 1 over cosine over secant, which is equal to 1 over cosine squared, which is equal to sine. So you tries. And the answers. So number 1 is cosine, and here is the work right here if you want to see it. So 1 minus sine squared is equal to cosine squared over cosine, and that leaves you just one cosine left in the numerator. So for number 2, the answer was cosine squared. So for number 2, the answer is cosine squared. So our problem was cosecant minus sine over cosecant. And that simplifies to cosecant over cosecant minus sine over cosecant. And you know you can just cross that one out because cosecant over cosecant is just equal to 1. So you're left with 1 over sine squared is equal to cosine squared. So in conclusion, reference angles are always positive, less than 90 degrees, and they answer the question, how close is the x-axis to the angle? Coterminal angles are integers of 360 degrees, 4 degrees, and 2 pi for radians. Remember the 4 quadrants and that the terminal side is after rotation. If you know the first quadrant of the unit circle, you know it all. For radians, every 45 degrees you add pi over 4, and every 30 degrees you add pi over 6. For degrees to radians, you just multiply by pi over 80, and you flip that, so you multiply by 180 over pi if you're doing radians to degrees. And lastly, you have to know the 11 trig identities, and you have to use them to simplify trig expressions. If you know sine squared plus cosine squared equals 1, then you know the other two. And